I'm Nigel Cook. I'm from the University of Wisconsin-Madison, so that's why I'm wearing red today. Been here 22 years tomorrow. 22 years tomorrow. October 1 I started. They haven't kicked me out yet. Longest I've ever held down a job, so it feels pretty good. So thanks for coming. We're taping this as well, so hi to those folks that are online. We're going to talk an update on ventilation cooling. And from my perspective, when it comes to heat stress, this is what I'm focused on. Lost lying time. We see a decrease in lying time of the order of about 3 hours a day when we experience the typical heat stress that we see in the upper Midwest. And that line keeps going down. So you folks in Arizona and Mexico and all around the world where we're experiencing increased heat, we're going to see decreased lying time. And I think that's a big deal. I think that drives lameness and a lot of the milk production loss and the fertility issues that we see during the summer months. And the other thing we see is this bunching behavior that drives everybody nuts. Because you build this big, beautiful barn. You put all this wonderful effort into these lovely stalls, these comfortable areas to lie down, and in the summer, the cows decide to live in half of it. It drives everyone nuts. Why are they doing this? Why are they bunching? It's because they're grazing cows, and when they're hot, they don't go somewhere cool, they go somewhere dark. They're taught to go to the shaded areas, and they're under a roof in a freestall barn, so where they go is away from the sidewalls and the end walls, and they usually mix in the middle of the barn. Most of the time, it's due to heat stress. Some of the time, it's due to flies. Right out here, there's a manure lagoon in this farm, and the flies come into the barn in the afternoon, and the cows can bunch because of flies. And then sometimes they bunch for another reason. Cows are very sensitive to air movement. So if there's parts of the pen where they can feel air movement when they're hot, they'll go there. And in this farm, they're all commingled down here, and actually they're all up here out of shot, but no one's standing in this area getting locked up when they're coming back from milking. Why? Because right outside the barn, where the wind's coming from, they're keeping all this hardcore ready for the next barn to be built. Ready for that. But it's blocking the airflow into that barn, and we're measuring airspeed. We can pick that up. That's a very dead area of the barn, and the cows are avoiding it. So cows are sensitive to air movement. Cows warm when they're lying down, and they cool when they're standing up. This is just one cow. This bar here tells you whether she's standing up. This bar here tells you that she's lying down. Every time she lies down, her body temperature decreases. Every time she lies down, her body temperature increases by about 1 degree Fahrenheit per hour. So she accumulates heat at about 1 degree Fahrenheit an hour. And then every time she stands up, she cools. And she cools at about 0.5 degree Fahrenheit per hour. So she accumulates heat at twice the rate that she can dissipate it. So when cows are lying down, they're getting too hot, and they have to stand to cool. And they have to stand more time to get their body temperatures down than they are lying down. And so we get that loss in total lying time per day. That's a big deal. So we have to focus on what's happening to the cow in those periods, because that's what drives the 3-day milk crash. This is our own little barn on campus. We used to put 50 cows in a little tin shed. It used to get super hot in there, and on the third high temperature day, our milk plummeted, and you'd see we'd lose 20 or 25 pounds of milk because of heat stress. It's a big deal. We have traditionally relied on soaker systems. We're using water to help cool the cows. We've got a little bit of a problem in this country right now. Climate change is driving the need to conserve water. So I don't see a future where we're going to be dumping large amounts of water into feed alleys. We're going to have to be much more cautious We're going to have to be much more targeted with how we use water to make sure that it lands on the cow, not in the alleyways. So shorter soaking times, higher targeted times for turning those soakers on, and longer intervals to conserve water. And the other big problem with soaking is while it does improve milk production and some of the other things that we measure, it doesn't seem to improve lying time. It doesn't change cow behavior, likely because the cows are standing where the waters are. We don't soak in the stalls, we tend to soak in the alleyways. So for me, that's why I've focused on ventilation to help cool the cows. You do that every morning with your hot coffee, you blow over the top of it. It helps cool the coffee down, yeah? Who doesn't do that? I don't do it because I only drink tea, but you know, whatever. It helps cool. So we need to use ventilation to help cool our cows, and we have not focused on ventilation enough with that regard over the last few years. That's been our primary focus. Not to ventilate just the barn, not to ventilate just the pen, but whatever we do to make sure that it impacts the cow's microenvironment, the climate trapped around the cow, so that we can keep her lying down. So that we can keep her lying down during periods of heat stress. Absolutely critical. So we have 4 requirements of any ventilation system, whether it's natural or mechanical, to target the appropriate airspeed in the resting microenvironment to keep the cows lying down. To make sure we have sufficient air exchange. That means turning over the air in the barn, making sure the hot, moist, contaminated air moves out of the barn and is replaced by the cooler air from the outside, less humid air. We want to make sure that whatever investment you make in ventilation systems, that it works as well in the winter as it does in the summer. And again, those hot climates, they've got an advantage. You just build it for heat and you turn it on and you leave it on all year round. That's not the case in the upper Midwest. We have very cold conditions in the winter, and that system has to work as well under those conditions, otherwise our cows are getting pneumonia and other problems that we don't want to create. And then from a producer perspective, it's absolutely critical that the investment is sound. We're asking these folks to spend more money on design, more money on running these systems. It has to be cost effective. So, a question for you, how fast does the air need to be for cows to like it? And you'd think, we're in 2021, folks, right here. Surely somebody's asked that question. And to be honest, they really haven't. We go back to the 1950s when a lot of this heat work was done. It really didn't get to the answer to that question. How fast does the air need to be? So we tried to answer that. This is a combined collaboration with Dr. Jennifer Van Os from our cows department, and this is Kim Reicher's PhD study. So we did this last summer. Our folks at UW-Arlington helped us out with this study, but we used these 51-inch variable frequency drive fans to manipulate the airspeed that these cows were experiencing during that summer. 2 pens, each with a set of fans covering each of 8 stalls, so a 16 cow pen, 16 test cows at each time, and then we went through control with the fans off, low speed and high speed treatments repeatedly, so that we went through about 128 total cows through the study to collect that information. This is the setup, trying to make sure that we're bathing all of the cows, so really making sure that we're getting somewhat uniform air speeds across that whole resting space, so that again we can keep cows lying down and learn what air speeds that we need. So what did we do? We had a low speed setting. That was 60% of maximum speed. The low speed setting made sure that we were above 200 feet per minute in all of the stalls. We actually averaged just over 300 feet per minute. That was our low speed setting. We had a high speed setting, was 100%, so full on. So we turned the fans full on, and the aim there was to get over 400 feet per minute, which we did, except for this stall here. And I think what was happening here was that the air was hitting the lip of the stall and bouncing over our anemometer, which is what we're using to measure airspeed. So I don't believe that 270 was actually true. On average, about 475 feet per minute overall. So those are our two fan treatments, and then the control was turn the fans off. And then you're just exposed to the resting airspeeds, which was very slow, about 38 feet per minute. So what did we find? This is lying time, so hours per day up here. The controls lost lying time when THI increased. Now we're talking about temperature humidity index, okay? So typically we're saying cows are impacted about a THI of 68, and you can see the decline in lying time that we saw in those cows. Later lactation, twice a day milking cows, hence the lying times are really good, okay? For all of the cows, they're really good. But the controls declined. What happened with our fan treatments, we actually maintained lying time. First time we've ever been able to show that. We maintained and actually even increased lying time as we increased airspeeds. There was a small difference between the two, statistically different, but we'll come on to whether that increase is actually worth it in a moment. Look at vaginal temperature. We're measuring that through these little star oddies on blank cedars inserted into the cows. We can see as temperature increases, the body temperature of the controls increases. But with fans, we maintain body temperature almost equally between the low and high speed treatments. And then milk yield. This is the bottom line for dairy producers. Does it make a difference? Yes, it makes a difference. We lose milk when we don't apply cooling and airspeed to the cows. We maintain or even increase milk when we do, of the order of a couple of pounds of milk per cow per day. It's measurable, you can see it. Let's get into this electrical cost, because our movement in our industry is towards variable frequency drive fans. So you can operate fans at reduced speed. This just highlights how important a concept that is, because when you run fans at 100%, this is the fan we used in the study, it costs this much per year to run. When you use fans at 60%, it costs this much to run. That saving is more than half. The difference is more than half. So the efficiencies of running a fan at a reduced speed is worth it. It's worth the cost of the controller, folks. It's a big deal. That's just for one fan. You run that for all of the fans, you're talking lots of money saved. So when we look at the difference between 60% and 100%, while there were some statistical differences, the bottom line is we got most of the benefits at much reduced cost. We could halve the cost of treatment by running at lower speed. So this is the conclusion of our study, that we can use airspeed to help keep cows lying down in the summer. Big deal. Prevent lameness, prevent the loss in milk. Those positive impacts were seen at about 340 or 4 miles an hour. Key point, not measured up here, measured where the cows are lying down, 1.5 feet above the stall, at the resting height. There are some incremental benefits to going faster, about 5 miles an hour, but then you have to factor in the cost of doing that. You've got to look at the cost of running the fans at that higher speed, and that may not be worth it. Depends on the situation. So there's a minimum cooling airspeed measured at resting height, 1.5 feet above the stall surface, minimum 2.25 miles an hour. You can go up to 5, but we're seeing some diminishing returns as we go beyond those kinds of numbers. So that information really allows us to start thinking about how we design barns and how we space fans. We want to make sure that cows are living in this area where we've got overlapped air streams from each fan, and they're being bathed in that 200 to 500 feet per minute fast moving air. And that means we tend to focus on closing up the fan spacing a little bit compared to what we used to do. Roof supports are typically 10, 12 foot on center, So we're going 24 to 30 feet with most of these smaller panel fans. Something like that. You can see every other roof post here, we've got a fan on it, and each row of stalls we see a fan as well. So even the cows living on the sidewall, we're supplying that fast moving air. And then look at the angle. That air is being directed steeply downwards to below the next fan along. It's not going over the top of the cows, it's going down into the resting space. Another possibility, a bigger fan or more fans. And so you can have a larger fan. There's a big one floating around right here. You can space those further apart. So you can use a larger fan. You can decrease the wiring and the busyness of the barn by using larger fans. Or you can double up fans and you can get that distribution of air with more distance between the fans, with hopefully savings in wiring and mounting costs. We're going to do that in naturally ventilated barns, and we're going to do it in tunnel ventilated barns because the cows still need that airspeed when they're resting, even in mechanically ventilated systems. So when we design tunnels, that's why you see fans like this over the lying area, not over the feed bunk. Remember, cows when they stand are already cooling. All we need to do there is exhaust the heat out of the barn. We need the fans and the airspeed over the resting area to keep the cows lying down. We're going to do it in cross-ventilated barns. We can do that in two ways. We can use a baffle. Here you see a baffle positioned over the stall surface, and that is driving that air into the resting space. So we're getting that fast-moving air where we need it using a baffle. But the big disadvantage of that is that in the winter at lower air speeds, that air gets trapped in the barn between the baffles. When we used to make these of solid tin, we couldn't deal with that. But in the winter what we do is we take the curtain up and out of the way. We use a curtain baffle, we can remove it in the winter, and that facilitates that air exchange during those critical periods at lower air speeds. So in a cross vent we can use baffles. But we can also do it with fans. So if you don't like baffles, if baffles offend you in some way, you can design cross-ventilated facilities with fans. And here you can see again these fans driving air into the cow resting space. The disadvantage of that is you're paying more money for more fans. Okay, so you make a choice with your decision. You can also do some interesting things with fans. You can put them on the sides of the barn, on both sides of the barn, and instead of exhausting air out of the barn, you can drive air into the barn. So here we've got a positive pressure system driving air into the barn. But remember, we need that airspeed in the resting space. So I believe you're kind of limited in these systems to these head-to-head platforms where we can get that airspeed at that point. So we're kind of limited with barn design with that kind of layout, but it is certainly an option for those 4-row head-to-head style barns. You're going to see some helicopter fans, HVLS, high volume, low speed fans that drive air down and out. And typically these have struggled to provide the airspeed in the resting space that we need. They're designed that way, low speed. However, I'm told there are changes occurring where they're trying to increase the velocity of that air movement, and hopefully we can see some improvements with these designs because, again, they provide a different aesthetic. I kind of like them for bedded pack barns because you keep the fans up and out of the way, and there are fewer obstacles to air movement in those bedded pack type arrangements. So when we started on this journey, I thought we were going to come up with one plan. You know, this is the perfect ventilation system, and what I've realized is there's different options for different situations. Whether you're focused on different climate extremes, when you're looking at different stall layouts, numbers of rows of stalls, in different countries where electricity may cost much more than it is. Can you imagine a country where it costs more than it is in the US? But in Europe it's 2.5 times more. So some of these systems just aren't economically viable in that type of situation. Your tolerance for fan maintenance, I'll come on to that in a moment. Some producers are not going to clean and maintain lots of fans. You know, find a choice that fits for those producers. And in some markets, we're going to have to make sure the cows can get outside. Can the cows do that with some of these systems? They can with some, not with others. And there's some other factors that come into play. So using this kind of decision support, we can select the best choice for a different circumstance. Fan choice is going to be critical. When you look at fan performance, you can see quite a range in operating costs. This is for a tunnel ventilated barn at 40 air changes an hour. And we can see a $20 per cow difference between fan choice in terms of cost of operation. That's part of the discussion you should have with your fan manufacturer as to which choice of fan we're going to select. Other factors come into play in terms of the type of fan, or whether it's got to exhaust against the wind and so on, that drive these decisions. Not just cost of operation, but it's one important factor to have a conversation about. And then, as I've said, maintenance is important. I see too many situations where producers have been sold a system where it's just not part of what they do. And if they're not willing to put in the effort to maintain the fans, to clean and make sure you're not losing 24 to 30% of fan performance, and turn a beautifully designed ventilation system into a disaster over the course of a year through poor management. So in summary, thanks for listening. We've got a wide variety of different ventilation options for our dairy cows. Right now in 2021, more options than we've ever had. And we need to think about the climate that we're housing our dairy cows in, the choices that we need to make sure these options are economically viable, and to make sure that they're effective all year round, especially in extreme climates where we have hot summers and cold winters. Fan choice is really important, and that's why I'm here. So thank you very much. Visit our website, Dairyland Initiative, if you want more information, and happy to answer any questions you may have. Thank you.